Hi there, welcome to this video. If you are sitting Edexcel Maths A level pure paper 2, which is next Tuesday on the 13th of June, this is the video for you. I've already done a short video analysing paper 1 and giving you some topics to focus on for paper 2, and in this video I'm going to go through some solutions of those topics. Nobody can actually predict the paper, and the exam board are really good at just giving you questions that you've not seen before, asking you in a slightly different way. But the best way to practice is just put yourself in that position, look at past paper questions and see how you would answer them in the real thing. So do use my previous videos as well, because I've done plenty of questions that do focus on the topics that we think might be on paper 2. Okay, let's get started. This first question is on the binomial expansion, and you get on the formula that 1 plus ax to the n is equal to 1 plus nax plus n into n minus 1 all over 2 factorial ax all squared plus n into n minus 1 n minus 2 over 3 factorial ax all cubed. So we're going to use that version, but we notice that this only works when we have a 1 as the first term in our bracket, and in our question we've got an 8. So we can rewrite that by taking 8 out as a factor, and then we'll have 1 minus 3 over 8x, and that will all be raised to the third. So when that 8 goes back in, it will cancel with this 8, and I would just have back my question. Because the 8 is on the front, I can then take that power in to both of those terms which are being multiplied in the bracket. So that will be 8 to the third times 1 minus 3 over 8x all to the third. Now I can use my expansion to expand that bracket. 8 to the third is just going to be 2, so that's going to be on the front, and then we can use our expansion. 1 plus nax, n is the power on the bracket, which is a third, so that's 1/3 times minus 3/8 x, and then plus n, which is 1/3, n minus 1. Well, if we're at 1/3 and we need to come down a whole 1, that's take off 3/3, so we'll be at minus 2/3 all over 2 factorial and minus 3 over 8x all squared. Important to have that squared on the outside. And then the last term we're after, because it's just after up to the x third term, would be n 1/3 n minus 1 minus 2/3, and take off another whole 1 will be down another 3/3. That will take us to minus 5/3 all over 3 factorial and then minus 3/8 x all cubed. Now we can tidy up. It's going to be 2 into 1. These 3's will cancel and we'll just be left with minus 1/8 of x. And then here I'm going to be squaring everything in this bracket. So I'm going to get a minus 3 squared, which is plus 9. And I can see when I'm dividing here, that will cancel with those. This minus will go because we're squaring, and minus times a minus is a plus. The 8 squared on the bottom is going to be 64. This 2 can cancel with this 2 on the bottom, but we've got this minus. So the overall sign is going to be minus, and it's just going to be minus 1 over 64x squared. Moving along, I can do the same to the next one. I've got 3 3's on the bottom here, and that cube needs to cube everything in the bracket, so that will cancel with that 3. We're going to have a resultant minus because the power is odd here. These 2 minuses will cancel and have 10. 3 factorial is equal to 6, and I can divide top and bottom by 2, so that will be 5 and 3. So all I need to do is say it's going to be minus 5 over 1536, which is my 3 times 8 cubed, x cubed, and then there would be more terms, but all I want is up to the x cubed term. Now all I need to do is take the 2 in, so multiply everything by 2. It will be 2 minus 1/4 x minus 1 over 32 x squared, and minus 5 over 768 x cubed. So 5 marks for doing that. Part B, it's asking us to use the expansion, what we've just done, to obtain an approximation to this is the cube root of 7.7, which is 7.7 to the power of a third. So what's in this bracket we need to compare to what we've just got an answer to, being raised to the power of a third. So 8 minus 3x, if we let that equal the 7.7 and solve for x, 8 minus 7.7 is equal to 3x. 8 minus 7.7 is 0.3. 0.3 divided by 3, x is going to equal 0.1. So you need to get what value of x is to then substitute that into the expansion. So if we do that, it'll be 2 minus a quarter times 0.1 minus 1 over 32 times 0.1 squared minus 5 over 768 0.1 cubed. And if you put that in your calculator, it comes out to be 1.974680099, and they want it to 7 decimal places. This next question is a trig question. We've got to prove the identity, and when you're doing that, you need to start with one side, manipulate it to get the other. So I'm going to start with the left hand side and write sine 2x as 2 sine x cos x. I'm going to write the tan x as sine x over cos x. So even though I want a tan x in the answer, I need to make a common denominator first and make a single fraction, because on the left I've got 2 terms and I need to make it just 1 term. So we need to have the left hand side all in sine and cos, because I need to take that line all the way across, which means I need to times this numerator by cos x. So I'm going to have 2 sine x cos squared x minus sine x all over that common denominator cos x. And then I'm going to take sine x out as a common factor on the top. Sine x, I'll have 2 cos squared x minus 1 all over cos x. And now we can see we're going to get the tan back again, because sine over cos is tan. And then inside here is our cos 2x. So altogether that's going to be tan x cos 2x. So that's part A. Part B, it says, given that x can't equal 90 or 270, we've got to solve in this range. And we've got here the left-hand side that we've just been dealing with, and we know that that is equivalent to this right-hand side. So what we need to do is use the right-hand side and say that tan x cos 2x must be the same as 3 tan x sine x. And now we're going to take everything to one side and take tan x out as a common factor. Tan x cos 2x minus 3 sine x is equal to 0. Two things timesing to equal 0, either the first thing does or this in the bracket does. So tan x is equal to 0, or what's in the bracket equals 0, and we can change the cos 2x and put it in terms of sine so that we can have a quadratic in sine. So cos 2x is 1 minus 2 sine squared x. So 1 minus 2 sine squared x minus 3 sine x is equal to 0. And then we can just rearrange that, take everything to one side. You'll have 2 sine squared x plus 3 sine x minus 1 is equal to 0. Now that doesn't factorize, but if you use the quadratic formula, you'll get that sine x is equal to minus 3 plus or minus root 17 all over 4. And then if you do inverse sine of that, you'll get that x is equal to 16.3. And if you do 180 minus that, you get the other answer, 163.7. And then we just need to solve for this tan x, and tan x is equal to 0 in the range x will equal 0 or 180 degrees. This next question is on implicit differentiation, and when you're doing that, you are differentiating with respect to x. So when you see y, you have to differentiate with respect to y, but then multiply it by dy by dx. So you just go along each term. So differentiating with respect to x, x squared is 2x, and then the next term is a product, so we need to use the product rule. So that is first, differential of second, differential of y is dy by dx, plus second differential of first, which is just 1. Now when you're doing second differential of first and just using that y, you don't differentiate, it's just y, and then the next term will be 2y, differentiating y squared with respect to y, and then because it's y, we multiply again by dy by dx, minus 4 minus 5 dy by dx, and then the 1 will be 0 and it'll still be 0. Now you have to take dy by dx out as a factor, so we'll have x plus 2y minus 5. Take everything else to the other side. I'm going to put that 4 as my first term, so it starts pretty with a plus on the front. 4 minus y minus 2x, and then dy by dx will equal 4 minus y minus 2x all over the x plus 2y minus 5. Now part B, it's asking us to give the coordinates of 2 points on C where dy by dx is equal to 0. Now it doesn't matter that our dy by dx has got y's and x's in. Sometimes you have to put in coordinates and you just put the x and y in. But here we want dy by dx to equal 0. That's only going to happen when the numerator equals 0. So we want to write 4 minus y minus 2x is equal to 0. For dy by dx to equal 0. So rearranging that, put that y over 4 minus 2x equals y. That's going to be where dy by dx is equal to 0. And then we have to go back to the original equation and put wherever we see y, 4 minus 2x, and then just solve for that one variable because everything will just be in terms of x. So we've got x squared plus x times y, which is now 4 minus 2x, plus y squared, 4 minus 2x all squared, minus 4x minus 5, 4 minus 2x plus 1 is equal to 0. So now tidying that up, x squared plus 4x minus 2x squared, squaring out that bracket, 16 minus 16x plus 4x squared minus 4x minus 20 plus 10x plus 1 is equal to 0. Now collecting like terms, we've got 4x squared down 2 but back up 1, so that will give us 3x squared. And then in the x's we've got minus 16 and a minus 4 gives us minus 20, back up 10 which is minus 10, and then plus 4, so that will give us minus 6x, and then in the numbers 16 minus 20, which is minus 4, back up 1, which will be minus 3, is equal to 0. So I'll go up here now. So we can take out a factor of 3, 3x squared minus 2x minus 1 is equal to 0. Only going to happen when that bracket would be really nice if it factorizes, but it doesn't. So quickest way to sort out the solution would be to complete the square. So we've got x minus 1 all squared minus the square of that number there, and then bring down the other minus 1. So that will be x minus 1 all squared minus 2 is equal to 0. Just unravel, x minus 1 is going to equal to plus or minus root 2. So x is going to be 1 plus or minus root 2. This next question is rates of change. We've got a large cylindrical tank, radius 40, water's flowing in at a rate of 4,000 pi. Look at the units. It's meters cubed per minute, so that is a clue to it's the volume that is changing. As soon as you see the word rate, you're thinking something is changing with respect to time. Now water's going in at that rate, but it's coming out at 50 pi h. H is the depth of the water in the tank. So we've got a tank, radius 40 meters. We've got water coming in, but then water going out. They're both in the same units. And what is that water doing? It's changing with respect to time, and it's the volume that's changing. So as soon as we see the word rate, we can write dV by dt is equal to 4000 pi minus 50 pi h. Now in part A, we're being asked for something that involves dH by dt. So we need to think what's a formula that's going to connect those two. So when you have a show that question, you need to end up with this equation, not start with it. So where after in this equation, dH by dt. So let's write down dH by dt. Now, because we've got the two variables, we need a linking chain that's going to connect those. So we need to start with what we want on the top, which is dH. The linking variable is going to be volume, so we need dH by dV times dV by dt. Now these things aren't fractions, but informally those dV's top and bottom can cancel, and then that would give us what we want, which is dH by dt. So we've already got dV by dt, which is told us in the question. We now need to find dH by dV. So what's the connecting formula with volume and h? The volume of a cylinder is pi r squared h. And if we get dV by dH, r is, we know, a fixed amount, 40 meters. So this is going to be 1600 pi. And then differentiate with respect to h, that will just go out. So now putting that in the chain, dH by dt is dH by dV, which we have got dV by dH, so we need to turn this upside down, be 1 over 1600 pi times dV by dt, which we've got from the question is 4000 pi minus 50 pi h. Now we can see everything can divide by 10, which is looking good. We're going to get 160 there on the bottom. Divide that by 10. We can take pi out here, so the pi's on the top can cancel with the pi on the bottom. So dH by dt is going to be 400 minus 5h all over 160. And then all we need to do is cross multiply 160 dH by dt is equal to 400 minus 5h. Okay, so that's part A done. When t is equal to 0, h is equal to 50, find the exact value of t when h is 60. So we've got a differential equation. Now we need to separate the variables and integrate because we want to get what h and t are. So if I cross multiply, put the dt up, I think I'll take the 160 down. So I'm going to have 1 over 400 minus 5h. Need to integrate that with respect to h. So these dh and dt's need to be in the numerator position. So the dt is going to go up. I've left the 1 over 160 on that side, dt. So now we're going to integrate with respect to h here. It's going to be the ln of 400 minus 5h. And then thinking about if I differentiate that, I'd get 1 over the 400 minus 5h. And then by the chain rule, I'd be timesing by minus 5. So I need to compensate for that and do minus 1/5. I would get an integration constant, but what we do is just lump them all together on the other side. So integrating the other side, 1 over 160 is just a constant, so that's going to be t over 160 plus c. Now we're given some information. That's always going to help us to find the constant here, which we've got as c. So when t is equal to 0, h is equal to 50. So let's put that in. Minus 1/5 the ln. When h is 50, 5 times 50, 250, 400 minus 250 is 150. When t is 0, we're just going to get that that is equal to c. So our equation is minus 1/5 the ln of 400 minus 5h is equal to t over 160 minus 1/5 the ln of 150. Now sometimes you have to get h the subject, but here we're just after the exact value of t when h is 60, so we don't need to get h as the subject. We can just now put h is equal to 60 in and try and make t the subject, solve for t. So we put h is 60 minus 1/5 the ln. 60 times 5 is 300, 400 minus 300 is 100, is equal to t over 160 minus 1/5 the ln of 150. Now let's take the 1/5 out as a factor and bring this ln over, which will be plus. So I'll take 1/5 out. I'm going to write the plus 1 first, the ln of 150, and then because this is a minus and then the rule of logs, we can just put that underneath. 100 is equal to t over 160. Just cross multiply 160 over 5, the ln. 150 over 100 is 3 over 2 is equal to t. Now notice it says exact value. It's not wanting us to work it out. Sometimes it does, and more often it does, because in a real life situation you more tend to give it as the decimal. But here it's asking us for the exact value. So 160 divided by 5 is going to be 32. The ln of 3 over 2 is equal to t. Here's a question that's going to use 3 different skills to integrate. So part A, we've got the integral of tan squared x dx. So we're going to use the fact that tan squared plus 1 is sec squared. So sec squared x minus 1 is equal to tan squared. And we're using that because tan differentiates to sec squared. So sec squared integrates to tan. So that's just going to be tan x minus x and then plus c. So 2 marks for that. Part B, use integration by parts. So you're going to use the acronym LATE to decide what is u. So L stands for log, so I'm going to say that u is the ln of x. So that will make dv by dx equal to x to the minus 3. And then we need to differentiate 1. So du by dx is 1 over x. Integrate the other. So integrating x to the minus 3, we need to add 1 on and divide by the new power. And then you do get the by parts formula on the formula book, or in the formula book it's uv. So let's put this one as minus 1 over 2x squared. Just tidying up, put that minus on top. X to the minus 2 is x squared underneath. So times in those two together, it's minus 1 over 2x squared, the ln of x, minus the integral of when you multiply the bottom two together. So we've got 1 over x times by minus 1 over 2x squared. So that will give us minus 1 over 2x cubed. So that's minus 1 over 2x squared, the ln of x, and then these minuses, let's make them a plus, the integral of a half x to the minus 3. Just bring that x cubed up, but leave the half underneath. So now let's integrate 1 minus 1 over 2x squared, the ln of x, plus a half x to the minus 2 over minus 2 plus c, and then let's just tidy up of x, and then this will make this minus. We'll have 1 over 4x squared plus our constant. Okay, part C, use the substitution. So using the substitution, u is equal to 1 plus e to the x. I like to get the dx on the go first, so we do that by doing du by dx, which will just be e to the x. So du is going to be e to the x dx. Now I can see the substitution is going to just be u on the bottom, but the e to the 3x is e to the 2x times e to the x. That would cause me to multiply them together, and I've got one of my e to the x here with the dx, so I just need to substitute for e to the 2x or e to the x all squared. So from the substitution, u minus 1 is equal to e to the x. So if I square that, I will square that, which will equal e to the 2x. So now I can make my substitution. It's going to be e to the 2x, which is our u minus 1 all squared, times my du. So then that will give me the e to the 3x, because I'll have another e to the x times by that, and the dx. So that's sorted all the top out, all divided by u. So what I can do now, squaring out that bracket, u squared minus 2u plus 1 all over u. Let's go up here. So then I can separate each of the terms. It'll be u squared over u minus 2u over u plus 1 over u. So this will be just integrating u minus 2 plus 1 over u. And now I can integrate, it's u squared over 2 minus 2u plus the ln of u plus c. And then we have to substitute back. U was 1 plus e to the x, so it's going to be 1 plus e to the x, and it's half, minus 2 of 1 plus e to the x, plus the ln of 1 plus e to the x, plus rc. So we've got 1 plus e to the x, so that should be all squared. So squaring out this bracket, we've got a half of 1 plus 2 e to the x plus e to the 2x minus 2 e to the x plus the ln of 1 plus e to the x plus rc. Take this half in, it's going to be a half plus e to the x plus a half e to the 2x minus 2 e to the x plus the ln of 1 plus e to the x. So if we got what we want a half e to the 2x, which is there, yeah, half e to the 2x, so that's that term. We've got an e to the x and a minus 2 e to the x, so that'll be minus e to the x. And then in the numbers, we've got a half minus a 2, so that's minus 3 over 2, plus the ln of 1 plus e to the x. Now, is that what we want? We've got the half e to the 2x, the plus, or the minus e to the x, and then the plus of that, yes. So what we've got here, notice it's a k, and we've got a minus 3 over 2 and a c, so they can just all lump together and just give us what we want. So we're just going to lump all those constants together, so it would actually be half e to the 2x minus e to the x plus the ln of the 1 plus e to the x, and then plus a k, where k is the integration constant, and then we've just lumped in the minus 3 over 2 as well. This next question is on points of inflection. So we've got a cubic, which is this shape, and when you differentiate a cubic, you get a quadratic. So the quadratic has its roots where the cubic has its max and min. And then when you differentiate again, where the quadratic has its roots is going to be there. Now at this point here, where it's the minimum of the quadratic, is the point of inflection, because you can see that the gradient is slowing down. It's positive, but it's slowing down towards the max. It continues to slow down and it's negative, and then as it approaches the min, it's going to speed up again. So the point at which it does that, which will be part of the way along, will be here. And so when the second derivative is below 0, this is where we are concave, and here this is where we are convex. So what we need to do is find the second derivative. So if y is that equation there, dy by dx is going to be 3x squared plus 12x minus 12. Need to go again and find the second derivative. So that's going to be 6x plus 12. Now in the interval between minus 5 and 3, so that's as long as x is between minus 5 and minus 3, is this function less than 0? Is it below 0? So if we find this point here where it does equal 0, so 6x plus 12 is equal to 0, 6x is going to equal minus 12, x is equal to minus 2. So that point there is x equals minus 2, and because minus 5 to minus 3 is below, yes, the curve will be concave. So as the second derivative is less than or equal to 0 in the interval minus 5 to 3, then curve is concave. So it's concave for this bit here until there, and then it's convex as the gradient starts speeding up. So part B, find the coordinates of the point of inflection. Well, we've already found part of that. The point of inflection is when x is equal to minus 2, and what we need to do to find the coordinate is sub minus 2 in there, and when you do that, y comes out to be 46. So the point of inflection is at minus 2, 46. Next, I've got a parametric equation. So we've got our third parameter t, and the first thing we need to do is find the value of p. So at p, y is equal to 0. So if we let 0 equal t minus 1 over t plus 2. So that only happens when the numerator is 0. So t minus 1 has to equal 0. T is equal to 1. And then what we need to do is sub that into the x equation. So when t is equal to 1, x is equal to 1 plus 2, which is 3. So p is 3, 0. 2 marks for that. B, find the Cartesian equation of the curve. So if we rearrange the x equation for t, so t is equal to x minus 2, and sub that into the y equation. So y will equal t, which is now x minus 2 minus 1, all over t, which is x minus 2 plus 2. So that's going to be x minus 2 minus another 1, x minus 3 over x minus 2 plus 2, all over x. So the Cartesian equation is y is equal to x minus 3 all over x. So that's part B. Part C. Find the equation of the normal to the curve at the point t is equal to minus 1. So the normal is an equation of a straight line, and we need a point and a gradient. So let's do the gradient first. To get the gradient parametrically, we need dy by dx, which is going to be dy by dt times dt by dx. So dy by dt is y is a quotient, so we need to do bottom differential of top, which is 1, minus top t minus 1 differential of bottom, which is also 1, all over bottom squared, t plus 2 all squared. So that, and then dx by dt is just going to be equal to 1. So dt by dx is also 1. So that's just going to be times by 1. And we want the gradient when t is equal to minus 1. So when t is equal to minus 1, dy by dx will equal minus 1 plus 2 is going to be 1. Minus 1 minus another 1 is minus 2, and minus 2 will be plus 2. All over the bottom squared, minus 1 plus 2 is 1, and 1 squared is 1. So the gradient's going to be 3. So the m of the normal is going to be minus a third. So all we need to do now is find the point. So when t is equal to minus 1, x is equal to minus 1 plus 2, which is 1, and y is equal to minus 1 minus 2 over minus 1 plus 2, which is 1, so it's minus 2. So we need to do y minus y1, which is y minus 2, so it's y plus 2, is equal to the gradient of the normal minus 1/3 x minus x1, which is minus 1, times everything by 3, so that will be 3y plus 6 is equal to minus x plus 1, everything to one side, x plus 3y plus 5 is equal to 0. 6 marks for that. Part D, find the coordinates of the point where the normal meets C. Well, we already know one of the points. It meets C at the point we've just found, which was 1 minus 2. So 1 minus 2, this is here, where the gradient was going to be 3, and we want to find the other place where the gradient is 3, because the normal is going to be perpendicular to the curve. So this is the point 1 minus 2. We just need to find this point. So what we need to do is let's rearrange the equation of the normal for y as the subject. So 3y will equal minus x minus 5. Y will be minus x minus 5 all over 3, and equate that to the equation of the line, which was over here. So if we let x minus x minus 5 over 3 equal the equation of the curve, x minus 3 all over x, cross multiply, you're going to have x into minus x minus 5 is equal to 3x minus 9. Minus x squared minus 5x is equal to 3x minus 9. Take everything to one side to make the quadratic term positive. You're going to have x squared plus 8x minus 9. That factorizes to x and x. Signs need to be different. We need to have plus 9 and minus 1. So where that equals 0, we've got here x equals 1, which is the point we've already got. So the other one is when x is equal to minus 9. So let's go into one of the equations. Let's use the equation of the straight line, which is here. So when x is equal to 9, y is equal to minus 9, which will be 9 minus 5 all over 3. 9 minus 5 is 4, so it's 4/3. So that point there is minus 9 4/3. Thank you so much for watching. If you're still with me at this point, best of luck for the exam on Tuesday. I hope I've been lucky and picked out some questions that are going to be really useful. They were based on what was not on paper 1, but you can never tell what's going to be on. Nobody can predict what's actually going to be on the exam. Do check out my other videos, because there will be plenty of questions that I've worked through that were on topics that weren't on paper 1. So best of luck for Tuesday. Keep an eye out. I'll do an analysis and put some questions together to help for the applied paper too. Okay, see you on the next one.